All right. So again, by popular demand. By popular demand, I've heard quite a few things about people wanting circle questions. Now, that being said, circle questions can have a couple different ideas or a couple different things when they're presented that may be a little bit more challenging or a little bit less challenging. I think that a lot of the times that the SAT introduces circle problems, they introduce them in terms of you need to know more about definitions than you need to know about, I guess you need to know more about definitions than you need to know about the actual equation that goes along with the circle. So I'll go through the equation of a circle after this. If you guys are interested in that or want to see stuff about that, I can talk about that for sure. But the thing that happens with a lot of circle problems, with this one and another one that you'll see later today, is you'll see that it relies a lot on definition. So just in case you guys are curious, the I can't see it. The SAT has a formula sheet that comes along with it. And for those of you that don't know what the formula sheet looks like, I'll unfreeze it for you. For those of you that don't know what the formula sheet looks like, this is an entire SAT. But as you get to the formula sheet, it will actually give you some stuff about circles. It will give you some stuff about triangles. It will give you some stuff about prisms and 3D shapes as well. But the main thing about circles that you have to pay attention to is that it will give you the area and the circumference formula, which those are a pretty big bummer because obviously it's only been a year since you guys have used this stuff, but people mix up the area and circumference formula all the time. They'll say that one of them is pi r squared, one of them is 2 pi r, and they'll get the wrong one in the wrong spot. So make sure that you utilize this sheet. Make sure that you pay attention to it because although it's not really sending you the most important information, it's important enough that you shouldn't mess up those little tedious formulas that they give you, okay? The other thing I want to draw your attention to while I have this out right now is I want you to pay attention to this part down here. You guys have likely never heard the word radian before, and you've likely never used it in a setting that the SAT is going to ask you to use it in, if they ask you to use it at all. So what I want you to pay attention to is it gives you two different things that are related to a circle. It says the number of degrees in an arc of a circle is 360, and it says the number of radians of an arc in a circle is 2 pi. It's giving you a conversion rate here, but it's not actually telling you what the conversion rate is. It's telling you that in one circle, a full rotation is 360 degrees, and in one circle, a full rotation is 2 pi. So you can create your own little proportion to help you solve questions if they ask you to convert degrees into radians. Now this stinks because this is something that comes from our chapter 10 or 11 in our book, which is like the last chapter of our book. So they're expecting us to be completely through algebra 2 if they ask you a question like this, which I have seen a question like that on SATs before. And I don't know how they can expect you to get through an entire algebra 2 class before algebra 2 is over, but that's just the way that they work. So just make sure you pay attention to these. Some people don't even see this, but there were people a few years ago that had seen this and they got a question about radians, right? If you'd like to, we can talk about them a little bit more in the next couple of days. But again, I've only seen it once on several SATs. I just wanted to bring your attention to it to know that it's there. Okay, so I'll go back here. I'll give you a couple of seconds again to try to figure this out, to think about it, to try to figure out what's going on with it. Figure out if you know what you're doing or if you don't know what you're doing. And then if you don't know what you're doing, see if you can take a guess. All right, so there's a couple different ways to go about this problem. If you remember yesterday, I had spent some time yesterday talking about, at least I hope I did in this class. I had spent some time yesterday talking about how the SAT gives you pictures and they tell you the pictures are not drawn to scale, but for the most part, the pictures are kind of drawn to scale. So what I want to think about this as is what kind of question this is before I start dissecting the picture, because I can't do anything with the picture until I figure out what I'm supposed to do with the problem in the first place. So the first thing says that I'm trying to find the length of the two semicircles when they're connected, right? So I want to find the length of one of the semicircles down here, and then I want to find the length of the other semicircle up here. In order to find the length of a semicircle, I'm talking about the distance around the circle, right? which is the same thing as the circumference. So I'm trying to find the circumference, which is 2 pi r, but I'm also only finding half of the circumference, which means that I have to divide it by 2. So I know that I have two different circumferences that I have to find. One of them is pi r, and the other one is also going to be pi r, but they're going to have different radii, right? So as I look at those, I have to figure out which one is which, kind of, right? This is one of those things, this is one of those times that I would very strongly suggest that you kind of trust your gut and look at the picture. So if this is something where I say that the distance from R to S is 12, I can kind of guess how long this piece is and how long this piece is, because otherwise I don't really have anything to go with. So now let's say that maybe like, I don't know, is it fair for me to guess maybe this would be like 1/3, 2/3? Is that kind of close? Because if it's kind of close with 1/3, 2/3, you could say, okay, well, maybe this is 4 and this is 8, right? So if one of them is 4 and one of them is 8, that's saying that the circumference of one of those is going to be 8 pi, and the circumference of the other one is going to be 4 pi. And if I want to find the total length of them added together, it's just going to be 12 pi. Now that's really great, except what if I picked a different number? Because 12 pi shows up. So what if I picked a different number? Well, let's say that maybe this one is 5 and that this one is 7. Well, if now we have 5 pi plus 7 pi, again, we get our way back to 12 pi. Did you guess C, Floyd?
I didn't guess,
You knew it.
but I didn't do it that way. I did it way more complicated.
Did you?
Yeah.
You want to explain it or no?
Oh, definitely not.
Okay. So, just a different way to do it, just a different way to think about it. Some people might say, well, what if the radius was just 12 or the diameter of the circle is just 12? We went all the way around and found the circumference. Then you could do that way too. This is just the way that I thought about it. Again, I kind of trusted the picture, even though I don't know if I'm supposed to trust the picture or not. It got me to a point where I could make an educated guess. Right? Now here's almost the exact opposite type of question. I'm going to leave you with this one. And I know that this is not super legible and I apologize. I'm trying to inflate something that was the size of a penny to something you can see. But here's another question for you guys to work on. And this is one that I'm willing to bet you guys will think is very easy and you'll get it wrong. Okay, I'm willing to bet that.
For that last question, is there a way that you can actually
Not necessarily, not really, because it doesn't matter what the radius is at all. Because in all honesty, if you're using two circles that have a combined radius together, like they give you the length of both of those things together, if you just calculated one big circle that used the radius that they gave you, you'd get the answer that you needed anyway. So there's almost no way to get anything other than 12 pi if you actually have some sort of a thought. But if you don't know what you're doing, then you're probably going to get something. Yeah.
So I was thinking as you went over our problem, and they're probably Germans as a whole don't pick it up, but the Germans are probably are probably the smartest Germans.
It could be.
Because they probably picked up English faster.
Could be. No. But I think they've also been doing English classes since they were in like second grade.
Yeah, I don't know.
All right. So hopefully you guys were able, with that little like warning at the very beginning, we're able to avoid the answer that we're very wrong. But what a lot of people would see, and this is very, very understandable. This is a very understandable idea. But one of the things that people would do is they would say, oh, this thing crosses at about 60 something. So the only answer that makes sense is C or D. That's fair. Except for the fact that 62 would have to be the y-intercept. That would have to be where the graph crosses the x or the y-axis. The only issue is this point is not 0, 62. This point is 140, 62. So since this point is 140, 62, that means the y-intercept is not 62. It can't be, because it's saying that the point is 140, 62. So this is skipping from 0 all the way to 140 in our graph. It just doesn't show you that. That's one thing the SAT does very often in questions that really aren't that challenging. This question is not that hard. The only thing is they will throw things at you in pictures with graphs where they'll change the scale of the graph without making any note or anything that will end up making your answers wrong. Like for instance, you'll see a lot of things, well, they'll go like this, and you know how I always go like this, and I put my marks here, and I'll say like, okay, each one of those is one, or I won't say anything because it's just gonna understood that they're one. All of a sudden, they'll just put one like 8 here, and they'll call that good. So that's like all they would do, but they're telling you when they do that, that each of those tick marks are worth 4, right? But that's not something that they're actually going to draw attention to, because you have to pay attention to detail here, or else you're not gonna get the answer right, okay? So right now, right off the bat, I should be able to say that C and D are not good answers. And guess what? C and D were the answers that people picked almost always in 2018 or whenever this was. So just kind of pay attention to those, okay? Now, even if you don't know how to solve this question, just looking at the graph without doing any work at all, we've been able to find out that C and D are not good answers, right? So you've at least upped your guessing probability to 50%, which I would rather have a 50% shot than a 25%. Okay. The next thing that you have to do is find the slope, because we already know the y-intercept is either going to be is going to be 32, right? So the only other thing that we have to do is to find the slope. The other issue that people ran into on this was they found the slope using points that were actually on the paper, not on the line. So like people would use this point right here because it's 420, 130, or this point right here, which is 300, 90. They would use those points instead of using the points that are on the line itself. Remember, this equation is about the line, not about the points. So I would pick something like maybe this point right here and maybe this point right here. Granted, they're not perfect, but they're pretty close. So I'd use the point 350, 110. And then I'd use the other point, which would be 280, 90. So then I would do 110 minus 90 over so 360. So 360. So 360 minus 280, which would give me something like 20 over 80, which is somewhere around the neighborhood of 0.25. Okay. So yes, there is no answer. So, and again, since I estimated this, I'm gonna have to know that this estimation has to be pretty close. And realistically, if I get a slope of 0.25, and the fact that I like this one is obviously not at that corner, right? I definitely made an assumption for what that point was. But since I got 0.25 for an answer and 0.21 is an answer, I'm pretty sure that's close enough, because like 0.04 can be guessed with a rounding, right? That can be fixed with a rounding. Now, if I got my answer and my answer was like 0.38, if my answer is like 0.38 or 0.32 or 0.35 or something like that, where it's kind of smack dab in the middle of these two, I'd probably pick 2 more points and I'd try it again. All right, so just kind of pay attention to that. I would say that this is a safe enough bet for me to move on and use that. Last hour, I think that we picked 2 points that ended up giving us 0.22. So there are points on here that are a little bit closer, but just kind of pay attention to that. Yes.
Would this be a calculator or a no calculator?
They'd probably let you use it here.
Use the calculator. Okay, so I'll type those.
You could do that too.
Or
Yep.
just type those.
You could also do that too.
Something like that.
But the thing is, if you don't know how to use your calculator, find a best fit line calculator will help. But if you do, that's fine. In all honesty, it's probably a little bit faster not to use the calculator though, which they're okay with too.
Yeah, but
Yeah, no, that's fine. I'm not saying like you can't use that, but I'm saying the way that the SAT thinks, they're always thinking efficiency. And if they're thinking efficiency, they're saying, okay, this person can do this question in 30 seconds without using a calculator, whereas that person can do the question in 2 minutes using a calculator. Let's give them their calculator. Because if they can slow you down, then all of a sudden, instead of giving you a very efficient, like if this was a no calculator question, you'd have no choice to plug it into your calculator, right? Which means that you would have to do it the efficient way. But if they give you your calculator, now all of a sudden you're thinking, well, I'm going to do it like this, and that's going to slow you down a little bit. They love that because they want you to fail this thing. They're all a bunch of jerks. I'm convinced that the people who do the SAT things are the worst people alive. Maybe not the worst people alive, but I don't like them. Serial killer. All right, here's another one. This is another circle question.
calculator question.
I honestly don't know. I don't know how your calculator helps. So, a couple things about this question. Okay, folks. A couple things about this. Number one, the idea of this question is not even the fact that it's a circle problem, because the only thing you need to know about a circle in this question is the fact that the area is pi r squared. That's the only thing you need to know, and that's stuff that you learned when you were in like 7th grade. But you have to understand that 99% of this question comes from definitions and you understanding what certain things mean. So for instance, it starts out with you absolutely having to know that the first quadrant is up here, or that I guess there are 4 quadrants in the coordinate plane. So it matters that you know that there are 4 coordinates or 4 quadrants in the coordinate plane. I guess it really doesn't make that big of a difference which one it's in, because realistically we're talking about a distance, and distance can only be positive. But what we need to pay attention to is we need to pay attention to what it means for something to exist entirely in one quadrant. So right now, if I tell you that something exists entirely in one quadrant, this is what most people would think, which is fair. That's a good idea. The issue is that we need to then follow along with the extra stuff that it gives us. So it says, well, this has to intersect at the x or at the with the y-axis at 6. But there's 2 things that you have to take from this. So first, you have to take from that statement that I know that my circle is for sure going to touch this thing at 6, right? But there's only one way that it can touch it. Because if I go through it, all of a sudden, in order to make it a circle again, it has to come back and go through it again. The second thing is, I also know that if I do this, I'm now in more than one quadrant. So if I'm in more than one quadrant, that can't happen. So that means the only way that I can make this circle touch is by doing something like this, right? So far I've kind of done everything perfectly for the first sentence. So I think that I have a good idea, and then all of a sudden the next part comes and it says if the circle intersects the x-axis at least one point, and they're trying to throw you off with this, right? They're trying to say it intersects at least one point. Let's make it intersect twice. But now all of a sudden, if you make it intersect twice, it crosses into the 4th quadrant. 4th quadrant, still good, can't work, right? So now we have an issue. So what we have to do is we have to realize that this is going to intersect with the x-axis only one time. And in order for it to intersect the x-axis only one time, it has to have the same radius, right? And I know right now, from looking at the way that this thing is from here to here, the radius is going to be 6. So this radius right here is going to be 6, which means that this radius also has to be 6. So if my radius is 6, then I know that it's going to end up being pi r squared. Pi r squared is the same thing as pi times 6 squared, which is going to give me 36. Big brain power. Good Lord. All right. Here's another one. Give this a shot, see where you're at. That's the number one reason I think this question gets wrong.
Yep.
Number one.
I see that and I go,
Okay.
okay, A, B, C, D.
I get it, because the thing that sucks about this even more is that this is the last part of the SAT. You go English and reading first, and then you do without calculator, and then you do with calculator. And by the time you're at with calculator, it's been like 3.5 hours. Your brain is completely fried. You're just, if anything, you want to do math, even if you like, you don't want to do math, but if anything, you just want to do like simple addition. And now all of a sudden they're making you read a full paragraph. So what you need to understand is I have a feeling, and I don't know why I have this feeling, but I have a feeling that most of the time these questions are challenging is because they're long, not because of what's in them, not because of the actual math, but because they're long. Because most people will give up before they even start the question. I remember being like that when I was in high school. I remember seeing questions that were too long, and I was like, yeah, I just don't feel like reading it. Let's go read it, right? Make sure that you understand most of these questions are very doable. Most of them are very doable. Just give yourself the time and the patience and understand that the test will be over soon. Just answer the question. All right, do your best to answer the question. I think a lot of the things that I hear are the same kind of things that most people are thinking throughout the course of the SAT. One, let's not read it because it's too long. And number two, let's not do math because why would we? Right? So a lot of people, what they're doing is they're looking at this, they're trying to reason it out versus using math. And if you use math for this, it takes like 30 seconds. If I realize at the very beginning, it tells me that she has a model that has a scale of 1 to 6. And then she says that her wingspan of her model is 10.7. How long is the actual model itself? This will take us seconds to be able to figure out, right? I think it turns out to be like 64.2. So it tells me that the actual model or the actual plane is 64.2 meters wide. And then we say, well, what happens if she changes the scale to be 1/3 instead of 1/6? And now we want to find the length of the model of 64.2. Now I'm taking 64.2 times 1, 3 times x, so I get 3x equals 64.2, and I end up getting 21.4. So I can now compare 10.7 and 21.4 and find out that the wingspan is twice as long. So again, this is something that took very little time and honestly, very, very simple math to be able to solve. It's just two things happen. One, you get exhausted because it's the 29th question of the with calculator part. It's wordy, and it's something that your brain is already so shot at this point that it takes an easy question and makes it more challenging just because of the context that it's in, not because of the actual question itself. All right. Now, I have one last question today. Last one looks like this. Yeah, that's a great name. If I ever have another kid, I'm naming him Longbow.
Yeah, this one actually makes me want to call
I want a question that doesn't have too many words, it doesn't have too many numbers, just right in that sweet spot.
This last one, it only had 4 numbers, so it just had a little bit. That is a lot. Yeah, not.
I think you're very overestimating how long I.
All right. So as we look at this question,
Wait, I didn't look at it.
couple things to think about. Number one, we want to figure out what the number of cell phones was in 2014 compared to the number in 2013. The only thing they give you is a percentage. Remember, a percentage is always something divided by something. So we want to think about this as the number of cell phones in 2014 over the number of cell phones in 2013. So what we're basically saying is we know that he sold more cell phones in 2014 than he sold in 2013, right? We know that because it says it's 128%. So he sold more. So I know that if I take the number of cell phones in 2014, subtract the number of cell phones in 2013, and divide it by the number of cell phones that were in 2013, it will give me 128% or 1.28. Okay, so that's the way that I looked at this question. Some other people did it differently. There are people in my third hour that just were saying things like, okay, so we got 2.28x. So they were just getting that in their head. Some of you might be able to do that. I wasn't. I couldn't do that in my head. So this would end up being y minus x equals 1.28x. I would add x to both sides. If I add x to 1.28, I'm going to get 2.28x. So that instantly right now gets rid of A and C. Now the last part, and this is the part that's kind of frustrating for me because percentages should make sense, but sometimes they don't. If I ask you to figure out how much your bill is going to be at McDonald's, including sales tax, what are you going to take your total and multiply it by? 1.06. Because if I just multiply it by 0.06, I'm only going to get 6% of my total, and the number is going to be smaller, right? This is the same thing. It says that the sales are 29% greater than they were. So choice A or choice B is basically saying that the sales would be 29% of my sales. And that's not right. It's 29% higher than your sales. So that means I'm going to include the current year sales and then add 29% on top of that. And that will show me how much more my sales were. So I'd have to multiply it by 1.29, which will tell me the right answer for that one.
Why do you look like that?
Any other questions, issues, concerns? Yes.
Do you think Hung Bo will make an appearance in our SAT?
I don't know.
He might. come
It would be
back.
cool if Hongbo was like a
If he
legend.
come back for the sequel.